Welcome to The Explainer. Today, we're going to talk about a number you think you know, the speed of light. But it turns out our understanding of it might be built on a ghostly mistake from the past, and a wild new theory might be here to fix it.
So let's just ask the big question right up front. Why? Why is the speed of light this unbreakable, absolute law? I mean, why can't anything go faster? It turns out the answer opens up a fascinating story about a flawed idea and a brand new one that could change how we see reality itself.
Okay, to really get to the bottom of this, we've got to go back. We have to start with the guy who pretty much carved the speed of light into the stone tablets of physics, Albert Einstein.
Look, Einstein's theory of special relativity is an absolute masterpiece, but it kicks off with a really big assumption, what physicists call a postulate. It just states that the speed of light, c, is constant for everyone, everywhere, no matter what. And the theory works perfectly, but it never actually explains why. Why is there a cosmic speed limit? It's just a fundamental rule of the game we have to accept.
But, before Einstein came along and laid down the law, scientists had a totally different idea about how light worked. And honestly, at first glance, it kind of makes a lot more intuitive sense.
They came up with this thing called the luminiferous aether. Just picture a giant, invisible jello that fills up every nook and cranny of the universe. The logic was pretty straightforward, right? Sound waves travel through air, ocean waves travel through water. So if light is a wave, it has to be waving in something. And that something, they thought, was the aether.
Okay, so how on earth do you prove this invisible space jello is real? Well, the idea was, as the Earth hurtles through space, we should be creating an ether wind. So back in 1887, this brilliant experiment was designed to detect that wind. The prediction was simple. The speed of light should look a little different depending on which direction you're looking. And the result? A big, fat nothing. The speed of light was exactly the same no matter what. This was a complete shock. It sent the entire world of physics into a total tailspin.
So yeah, the ether was pretty much dead on arrival. But what if I told you that, after more than a century, the idea of space having some kind of medium is back? And this time it's in a way that is just completely mind-bending. Now hold on, we have to be super clear here. This is not your great-grandpa's aether theory. This isn't Aether 2.0. The old idea was a rigid, static background for everything. This new concept, the dynamic vacuum field, is the complete opposite. It's alive, it's flexible, and it's fully relativistic. The old aether would have broken Einstein's theories. This new idea might actually build them from the ground up.
So, what's it called? It's dynamic vacuum field theory, or DVFT for short. And the core idea is pretty wild. What we think of as empty space isn't empty. Not at all. It's a physical medium, a field, with real properties that you can describe with math, like density and stiffness.
And here's where it gets really good. If the vacuum has actual mechanical properties, guess what you can do? You can calculate the speed of a wave moving through it. All of a sudden, the speed of light, c, isn't some magic number we just have to accept. No, it becomes something you can actually calculate. It's just the square root of the vacuum stiffness divided by its density. We go from a mysterious rule to a physical calculation.
And this analogy is just perfect. Think about the speed of sound. It's not a random number, right? It depends on the properties of what it's traveling through. Air, water, steel. This theory says the speed of light is the exact same kind of thing. It's not arbitrary. It's a property that emerges directly from the fabric of space itself. For the first time, c actually makes physical sense.
Okay, but here's the part that might just blow your mind. This whole idea doesn't throw Einstein's relativity out the window. In fact, it might be the thing that finally explains it right from first principles.
All right, stick with me on this, because the logic is awesome. Step 1. The vacuum is a real physical thing. Step 2. Light travels through it at its top speed, c. Easy enough? Now here's the kicker. Step 3. What has to happen for someone moving through that medium to still measure the speed of light as c? Well, the only way it works, step 4, is if the medium itself physically warps. All that weird stuff from relativity, like time slowing down and distances shrinking, they stop being abstract rules and start being actual physical effects of moving through this dynamic vacuum.
You see how this just flips the whole thing on its head? Special relativity says, hey, we see that c is constant, so that must mean time and space have to warp. This new theory says, no. The vacuum's physical mechanics cause time and space to warp, and the result of that is that everybody measures c as being constant. It gives us a physical cause for all the strangeness. But if you think this is just about explaining the speed of light, you're in for a surprise. This idea has its sights set on, well, on pretty much everything.
Remember the old ether? It was a one-trick pony. It was just there to explain light. But this dynamic vacuum field theory is more like a Swiss Army knife. It's trying to solve a whole bunch of physics problems all at once.
I mean, check this out. Gravity? Maybe that's just a ripple in the vacuum's density. Electromagnetism? That could just be a wiggle in its rhythm, its phase. And what about the biggest mysteries in the cosmos, like dark matter and dark energy? Maybe we don't need to invent brand new particles. Maybe they're just different ways this single vacuum field behaves.
And it gets even wilder. By grounding physics in the real properties of the vacuum, DVFT claims it can solve one of the biggest embarrassments in modern physics, a mismatch in the predicted energy of the vacuum that's off by a 1 followed by 120 zeros. It is a ridiculously huge error. DVFT claims it can make that problem just go away, simply by getting the physics of the vacuum right.
So look, while this is still a developing theory, for sure, it paints this incredible picture that the universe's deepest secrets aren't hiding in some exotic particle, but in the seemingly empty space all around us. It leaves us with a profound question to chew on. Is the vacuum itself the hidden source code for all of reality?